Welcome to Introduction to Data Analytics with Spark. There is an explosion of data. No matter where you look, data is everywhere. You get data from social media such as Twitter feeds, Facebook posts, and a variety of others big data sources. The need to be able to process those data as quickly as possible becomes more important than ever. And here, the big data analytics and tools are helping to process big data. There are many existing tools and technologies for big data analytics, and we choose to use a Spark as it provides not only data analytics of historical data but also in real time. So it provides a streaming of data and process and analyze in real time and creates real-time dashboards. And it also has a Twitter streaming API where it already provides a streaming of tweets and in real time. So that way you can create real-time Twitter analysis dashboards. So you may ask, why would I want to use Spark and what would I use it for? There are two groups that we can consider here who want to use Spark. It's data scientists and data engineers. You may ask, but aren't they similar? In a sense, yes, they do have overlapping skill sets, but for our purpose, we will define data scientists as those who need to analyze and model the data to obtain new insight of the data. They would have techniques to transform the data into something that they can use for data analysis. They will use Spark for its analysis to run interactive queries that will give them results immediately. Data scientists may also have experience using SQL, statistics, machine learning, and some programming, usually in R, MATLAB, or Python. Once the data scientists have obtained insights on the data, and later someone determines that there is a need to develop a production data processing application or a web application or some other system to use these new insights, the person called upon to work on it would be the engineer. Engineer would use Spark Programming API to develop a system or application that implement business use case. Spark parallelizes these applications across the clusters while hiding the complexities of distributed system programming and fault tolerance. Engineers can use Spark to monitor, inspect, and tune applications. So, what is Spark? Apache Spark is a lightning-fast cluster computing technology designed for fast computation. It is based on Hadoop MapReduce, and it extends the MapReduce model to efficiently use it for more types of computations, which includes interactive queries and stream processing. Spark is one of the research projects developed in 2009 in the University of California, Berkeley, AMP Lab by Matej Zaharia. It was open source in 2010. Later it was donated to Apache Software Foundation in 2013, and now Apache Spark has become a top-level Apache project from February 2014. The following illustration depicts the different components of Spark. The Apache Spark core is the underlying general execution engine for Spark platform that all other functionality is built upon, like a Spark SQL, Spark Stream, and machine learning and graph. So Spark SQL component is a component on top of Spark core that introduces a new data abstraction called schema RDD, which provides support for structured and semi-structured data. So it allows you to load JSON and CSV files that has difficult structure, that have nested JSON or nested arrays. It helps you very easily to load the data to Spark and make the further analysis. Then the Spark streaming is another component that is provides real-time data analysis, and it introduced a new data abstraction called DStream, decentralized stream. It's a list of RDDs. RDD is resilient distributed datasets. And then another one library is machine learning library. It's a distributed machine learning framework above Spark because of the distributed memory-based Spark architecture. So it contains a list of well-known or most used machine learning algorithms, the classification, clustering, and so on. And also GraphX, the last one, the GraphX library, is a distributed graph processing framework. On top of the Spark, it provides an API for expressing graph computation that can model the user-defined graphs by using Pregel abstraction API. One of the main features of Spark is in-memory cluster computing that increases the processing speed of an application in many times. And it also supports multiple languages. So Spark provides built-in APIs in Java, Scala, Python, and R. So therefore you can write applications in different languages. Then it also provides advanced analytics. So Spark not only supports map and reduce, but it also supports SQL queries, streaming data, machine learning, and graph algorithms. And resilient distributed datasets called RDD is a fundamental data structure of Spark. It is an immutable distributed collection of objects. Each dataset in RDD is divided into logical partitions, which may be computed on different nodes of the cluster. RDDs can contain any type of Python, Java, Scala objects, even including the user-defined classes. It is a read-only partitioned collection of records. And there are two types of RDD operations that can be performed on them. It's transformations, they are lazy evaluation, no return value, and actions that perform the transformation and the action that follows. They are returning the value. To create the RDD, watch other tutorials with the system preparation and Hello World tutorial, how to create the RDD and run Spark application. To use Spark, to write Spark applications, there are many different solutions and IDEs, depending on which language do you want to choose, or Java, Scala, Python, or R. So there you can use text editor, you can use the Scala IDE for Eclipse if you want to use Scala-based Spark application. You can also use Intelia JetBrains that supports both Python and Scala-based Spark application. It has also Spark plugin. You can use also a Spark shell to debugging and quick play around with Spark basic functionalities. You can also use a notebooks that provides not only data analysis but also provides interactive visualization, like Jupyter, Python, and Zeppelin supports Scala and Python. To set up development environment, please watch the following tutorials. for Scala, Python, or Zipling. Yes, and if you have any questions in class sessions, in lab sessions, we will use a Scala IDE and Scala-based programming application, but also I will provide examples on both on Scala and Python. So, and also if you have some problems, questions regarding the installation of environment of Spark or assignment task, please come on Open Lab session that is happening every Friday from 10 to 12 in D2270A. That's all.